is our Thomas UNC 1000. We previously had a UNC 750 for prototyping. That was a nice machine, but we need something bigger for our camera. So this is kind of what we moved on to. This right here, this is one of our pieces for our new machine. We're building a larger 5-axis mill, and it's nice because we do all of our prototyping on a 5-axis mill. That kind of allows us to put on features that would be either more difficult or time consuming if we were just using 3-axis. As you know, we're big fans of the 5-axis stuff.
Yeah.
Shot of the tooling. This is some of the tooling we've started acquiring for the actual manufacturing of the 5-axis mill, and you can see some of those guys get a little bit long. Oh yeah. Is the only person Michelle? No, it looks like there's a bunch of other people. Yeah, we produce a lot of chips. I've seen a lot of people use totes or little bins, little recycling cans for moving their chips around. We use Gaylords. These are I guess about the biggest box you can fit under one of these machines. It's, as you can see, it's a full pallet worth of chips, and that's been nice for production. Yeah. So, moving on. This is our juice on here. We got this UNC 750 this last year. The machine just had a lot of hours on it, and we wanted something with a little bit more thermal compensation. So you can see right now it's running the production parts for the Pocket NC mill. This is a V210 spindle mount, and
we still have quite a few people joining us.
Yeah, so if you're just joining us now, we're checking out the Doosan, which has been our production machine for the V2 parts, 10 and 50. And what's the other machine?
Well, the V250 variations.
Oh, we have the V250 variations.
Yeah. CHK and CHB.
Yeah. And then over here we have the robot rack. So all the parts get loaded on as a piece of stock. And then the robot can grab this little pin and it puts it in the machine using its gripper, and it sets it into a Shunk 0.4 holding, and then the machine probes the material, checking to make sure we've actually loaded the right part, and making sure the stock is the right size. And then it cuts it, takes it out, and gets it out. And so this is some of the production that's run. This is nice because, like, right now, there's nobody running the machine shop, and there may or may not be someone that comes today to run the machine shop, but it allows us to keep production going. So.
Well, we have part-time machine shop operators.
Yeah, we have part-time machine shop operators.
Not just robots.
Not just robots, right? Somebody has to do that.
Right.
Yeah, and we'll come back to this when the part is swapped out. I'm not sure when it will be.
Okay.
Yeah, and then over here again we use one of these Gaylord boxes. This is nice. That have to do anything really to get the chips out the door. We just load this onto a truck, and they bring us a new box, and it lets us focus on where we make money. Over here is kind of where people check parts and load parts on the fixturing and stuff. Just got a bunch of tools and whatnot. Yeah, anyway. Over here is where we keep some of our excess stock. Some of it we're running low, like we have no more 3.5-inch plate material, but I think that's for the trunnions. And it looks like we're out of main block material as well. But we get deliveries every week or two, and so yeah, let's this is our original mini mill. It's still going strong. We just looked at the numbers today, and it has 31,000 tool chains.
Whoa.
It's impressive. Congratulations. It's lasted a long time. We use it for cutting our socks, like I said. Gaming's ready for the new song. This machine when we bought it wasn't particularly fast. And we use it for all of our original machines, our V1 and all that production. So it's been around with us for a long time.
Do we still make some accessories on it?
Do we still make accessories?
Yeah.
I think some, yeah, you're right. No, some does. And some of that's getting transferred over. And we'll probably replace it with another boss machine. It's great for the production of movement. That's 3-axis stuff. It's really good.
Michelle commented that it was in your garage.
Yeah. So, back when Michelle was pregnant with our first kid and it was in our garage, I would go to run anodized parts out to like the edge of town, and she would have to go out there. We had to get like work done, so she would go out there and like crank it. But we were too cheap to buy a torque wrench, so she didn't know how to. And I was like, all right, most of your body weight at this area, not just how to calibrate it or how tight to get it. Obviously, this is coming away. So, yeah, these are. So there is one op that gets done. So for the main blocks on the mini mill, you can see this is some of our work holding holes, and so the mini mill puts in these holes, a couple delta pin holes, and a couple of M6 holes.
Oh, is it changing a part right now?
Oh yeah, it is.
It's changing part.
Don't look at through the door. Well, you can see that, yeah. But then you should come over to the robot rack.
Yeah, I can move quick.
So, you should come over here. The robot.
No, it's good.
The robot dunks it in this dunk tank to get off any of the excess coolant and chips so it doesn't go on the rack, and then kind of drips off some of that excess water.
Oh yeah.
And then it should just grab the part right next to it. So a lot of you guys probably noticed that we have 5 Shunk fixtures in there, 0-point fixtures. The original idea was that we would also run some of our other stuff on those fixtures, and we really haven't utilized them. If any of you guys are looking at getting into the Shunk fixturing, consider just getting a single point fixture with they call it the V1 notch, and so you can see there's a little, you may or may not be able to see. Hey, hi Ed, how are you doing? There's just a little single notch in there that keeps a clocking pin from rotating on the fixture, and that's pretty nice. move in and give a closer look. It's kind of hard to see. Yeah, I mean, this is our half-inch rougher, and yeah, I don't honestly remember how much material it's taken off or anything, so nothing super interesting to say there. Anyway. Let's go to my office. So this is where most of the prototyping I do is done. Work at this desk. Sometimes Michelle joins me, which is awesome, and it's kind of like nostalgic. We have a napping couch, so like, or thinking couch. I do a lot of my deep thinking while I'm like almost asleep. Just kind of on the edge there, which is nice. That's how a lot of stuff comes to be. This is the solo machine, or just like we're just starting to build some stuff, put it together for the 4th version. So we cranked on 3 different versions so far, or mostly put together, and each of them had something that we wanted to change or improve upon. And then with the 4th version, what we really wanted to do was get in some of the final features that we knew were important, but we just didn't have time to get in. So some of those are, here, I'll show you this. Oh, can you?
Michelle said it was loud. Oh, yeah.
Oh, yeah, cool. So with like real industrial machines, you have this problem where all the grease ends up going away, and on an important bearing surface, and so the machines kind of get destroyed. So we have grease lines that there'll be grease poured in from a main source, and then it goes through all the different tubes and lines, and then goes to important grease points. So like this goes to a ball screw fixed bearing, anyway, so like in there's some fixed bearings, and the grease goes through and feeds them, and yeah, all the linear guides have to have grease to it, and we only grease one car, but we make sure the system as a whole gets greased. And then another big one, as maybe some of you guys have seen, the cooling holes. This was particularly difficult to find it, because the block is a little bit of a piece of Swiss cheese on the inside, but the cooling goes up here underneath this rail, and then through this little crossbar, and then it comes out here and goes straight up. So we had to drill a cross-section hole through this, but the path is up through here, behind this rail, and then back down and out there. And we did that for all the pieces. So this one has cooling. I guess not all the pieces, but all the pieces that have something that will generate heat or is connected to something that will generate heat. So this the first Y unit has cooling in it, and you can see the cooling holes, so it comes through and goes let's see, under this rail, and then it kind of sorry if I'm making anybody sick. And it comes back here through this U, down, and then back out through this. And I mean, some of it's getting pretty tight, right? We had to go through this little triangle with that 8mm hole. And then we also, this
this is like the duds machine. So this is this is the version 4 full of mistakes. So it's got like little nicks and crap on it. But anyway, and then you can see the cooling on this one. This one is probably the most important that it's cooled because it is connected to the spindle motor, which is generating a lot of heat. And so this whole like Y stage here will generate a lot of heat and grow in length and cause the Y-axis to be out. We also, we put it on everything that basically we figured would cause some sort of thermal growth issues. Like one of the reasons we go all the way around this, the B reducer is because it does generate heat, and so it needs to be cooled. But yeah, so that's some of that. This is like some of the crap we've accumulated over the years for prototyping this, so I'm sure some of this will go away. If you're working on a cool project and you need something for it, I may consider giving you some of this junk. Like all this stuff on this first shelf, going away. This is all getting used for the new machine. This is also getting used for a new machine, going away. Anyway, let me know if you want some of that. Same with a bunch of this stuff. This is Carrie, by the way. Carrie generates all of our revenue, so she's very key to the business. Yeah.
Production.
Right.
Generates all of our revenue.
Well, anyway, and then this. So recently we switched to Shunk tooling for what we really noticed was we weren't going to save a bunch of money by doing it, and we weren't going to increase tool life that we really had calculated, and I'm sure there will be some of that. But I think the really nice thing for us is when we're running these production parts, it allows us to set up tools in a way that we don't have to worry about run out. So we just know that people are going to get it perfect every time, and it just takes the pressure off the person who's setting things up to make sure they do it right. Like we had an instance, and this happened multiple times, where somebody would say, "Oh, a tool's not running right because it has a lot of run out," or they would say it's not running right, and it ended up being because it had run out. And with call it, they would end up sometimes having 3,000ths run out, and it was maybe because of a chip or any number of reasons. They didn't get the call it in there quite right, and so we switched over to this because instead of having at worst case 3,000ths run out, you might have worst case 3/10 of run out. We usually only see about a tenth. This is pretty cool if you haven't seen this before. So this is one of our solid carbide drills. It's a 10.5 millimeter flat bottom drill. So we'll use this for drilling some of our M12s. And it's pretty cool because you just jam it in here, and then you can just crank down, pull the drill out. I feel like a fool now because I didn't get, oh, there we go. Usually you have it in its tool holder. It makes it easy to rotate, but then I realized it wouldn't do. Yeah, and then we just pump it up to 280 bar. And then, so somebody just pulls out the drill. The heat shrink stuff is pretty nice. I think the heat shrink stuff would probably work better for like end mills and stuff. This is pretty nice for our drills, and we'll probably consider some of that in the future. But for where we're at now, this has been a huge win for us. And then we know the tool set up perfectly. Not to keep going on this, but so ignore the massive amount of welded aluminum to it. This is with all of our production parts, we probe the material and make sure that it's the right part, it's the right size of material, it's in the right position, and we do that all before we run the production part. And so some of the reasons we do that is the wrong part was loaded, and this just kind of like buffed, after it snapped off the end mill, it just buffed away a bunch of aluminum and until it finally pushed it out of the work holding there. And luckily at that time we were using dovetails, so it just kind of like swaged its way out. Anyway, so one of the reasons we switched to Shunk is so we had been using some kind of metal hydraulic holders, and these were about $500 a piece, I want to say. Whereas the Shunk ones, we've had just as much success, and I believe these hydraulic ones are about 200 or something. They're significantly cheaper. It was cheaper to get one of these new than to pay for a repair on one of those. So, and we did have a few kind of metal tool holders fill. But if you're thinking about setting yourself up with some good hydraulic holders for some really precision end mills, you should definitely consider the Shunk stuff. Well, we won't get paid by them to say that, but it's just like it really has been a win for us. Yeah. Anyway, do you think you guys should cover anything else in here, Carrie?
Do we want to ask if there's any other technical questions about the machine?
Yeah.
Does anybody have any technical questions about the new machine before we move on that don't have to do with the release date? Because we don't have an answer for that quite yet.
The answer to nobody on release date.
It looked like you and Elon Musk were hanging out for a second together.
So I don't fully know who put that in my office.
It was here before I started.
I came in one day and it was in there. You showed that?
Yeah. Well, you guys looked like you were hanging out together.
Oh yeah, I wish. That'd be too cool.
Oh, build volume.
So we're designing the machine to be able to use a 5-inch chunk, or sorry, 6-inch chunk of material. There's still a few things that may cause that to fluctuate. So I think in some cases you could get a little bit bigger than a 6-inch by 6-inch by 6-inch. But there's some things that 5-axis is tricky because there's all these clearance issues, and if you don't design the machine to build it collide with itself in some places, which sounds weird, you basically give up a bunch of like areas that you can go to, and so in some cases you'll be able to fit bigger than 6 inches, and in some cases it will be smaller. So it just depends on what you're doing, but that's the goal. So like our current machine, like you could fit a 3-inch cube on there, but you are going to be maxed, right? It really works really well for probably a 1.5 with a 2-inch cube being on the bigger side of what you should be doing. And this thing, I'm guessing 5-inch cube will be on the bigger side of what you should be doing, but I do think you'll be able to make it work with a 6-inch cube. So that's a tricky question to answer, but it's one I can appreciate, because like that is, I know when we're doing stuff on like our Haas UMC, it is always a question when it's going to fit, and there's things we've done that are like unconventional, to put it nicely. So there's definitely some things that are too big for it, but we've had to get a little clever, because there's some extra travel by the tool changer. So if you like kind of manipulate your programs and maybe have multiple work offsets so that you can utilize that area, and if you're careful about how you rotate parts around, you can just barely miss the tool setter, which is nice. Anyway, so there's some things that, I mean, people always use machines for a little bit more than they're intended for. That's just the nature of it.
Chip management. AJ asked about chip management.
Oh yeah, no, that's a good
what
question.
That'll be.
So you can't see it here. So the plan is just to have a chip bin that somebody pulls out. Now we are designing the machine to function for automation. So like the automatic door, the automatic module for holding on to vices and automatic vices. Just give me half a minute, okay?
Okay.
This is like,
And then there's some questions about the spindle too after chip management.
this is a special drawer. This is like all little Shunk stuff we have that we need to get set up. But so the chip management, what we're hoping to do, I think at first, is utilize. So this is like this is the little mini 90 chuck that holds on to.
Oh, in the coolant situation, Datron style MQL.
What is MQL?
They're mist.
Oh yeah.
Like,
So we'll be set up for this, but we want to use the same head style for the chip bin to be able to pull it out first. So it's a little bit weird, and I use that word unconventional, but basically the same stuff that our gripper holds on to, and to be able to remove the chip bin. And then, but we designed the frame of the machine to we designed this frame of the machine that this sits on to actually accommodate in the future an automatic chip conveyor. But the release date on that will be down the line, and I think probably we'll release something with automation to like automatically load and unload the machine before we do the automated chip stuff, because I know this is kind of like running on, but if you can't automate the machine, then you probably don't need to automate the chips leaving. But I think the chips will leave in the back when they do finally become like a chip conveyor. Yeah.
do you want to do coolant at the same time? Does that
Oh
sort
yeah.
of go with that?
So Coolant, it's nothing super fancy. It has a coolant tank and a coolant pump, and it's digital, so you can actually adjust the amount of coolant. If it doesn't become high enough pressure, we'll probably do something servo related. But for now, I think it actually will be enough, and it will be probably similar to more like a mini mill, where it's more just a flow of coolant, so keeping your parts flooded and your tool covered in coolant. And so this is one of the little coolant nozzles. It's just a little 5mm nozzle, and it screws in on the side here. It's kind of hard because it sits at an angle, and that's how we just got to have the best coverage of the part. Oh, there we go. And then obviously it's not tightened, but then it would allow you to, if you go from this side, I think it does see more.
It will be better.
So the coolant nozzle, will spray down on the tool, and like you got your little tool, and then you the coolant comes in right here, and feeds through the system with a bunch of other stuff.
Will tools with through coolant be able to be utilized?
No, not on this, and not at first. I do hope to do that someday. That's actually a pretty big redesign. So the company IMT, who we're working with right now, this is basically the same spindle used on the Datron Neo, with the exception that we chose an HSKE interface instead of the direct shank clamping.
Speed and horsepower of this? That was a question too.
Right, I'll get there.
Okay.
No, it is a big height add-on. We left the room for it. I think we'll be able to get it on there at some point. It is tricky, and it will require testing, because I think done wrong, it would just destroy the spindle. So that it's something I definitely can appreciate and want, but it's just going to have to be at a later date. RPM. So in the U.S., I think we'll be able to have 40,000. But outside of the U.S., without special permissions, I think it'll only be 36,000. And so that's because of non-nuclear proliferation. That
Oh, really? Our export?
Yeah, the VFD frequency. But if you might be getting stuff for those guys anyway, so it might not matter. Right?
Sure.
That's a little bit yet to be determined, but it's limited by 599 hertz, and then the frequency of the motor. But and something maybe you guys can weigh in on this, but this is a 36,000 RPM motor, and I think honestly people will be more happy with an 18,000 RPM motor because the torque is over double, and then it also allows you to use a wider variety of tools. So you're going to be able to do more things like steel and without wearing out your tools, compared to with a 36,000. I know some of that's changing, and coatings are getting really good. And if you look at things like in the dental industry, they mill super crazy metals.
So maybe some options
definitely
spindles.
Definitely some options. But
do you know the power of this one and also the max tool diameter it can?
Right. So the S1 is 2.5 kilowatts. So that means it can run continuously at 2.5 kilowatts. And then I want to say S6 means 60 seconds. But I'm actually a little rusty on that one. It's been a while since I've read that. But it says 3 kilowatts. Okay. So this will also kind of be dependent on how you run your machine. So we've designed the machine to be able to be run off of a power inverter. That the power inverter will. You should show some of this, Carrie. Just go around. But the power inverter can run from 110 to 220, and the nice thing about that is, if you have a 20 amp circuit, you can do a pretty good amount of machining with just just the 110 wall, and it stepped up to 220, and that's pretty nice for people who are in labs or their garages or whatever, and may not have a 220 outlet right at first, or maybe they just don't even plan on doing that. And all of our testing has been with 110, and we just get limited by the wattage. So between 2200 and 2400 watts. It will matter a little bit on your power too, right? If you're running 240 versus 220 or 208, that you do get obviously a little bit more out of it, wattage wise.
Tool diameter, max on that.
This is a 20 millimeter, I believe. Okay. I think people are going to be most happy running 6, 8, 10 millimeters. I think like a 6 millimeter tool is very complementary to the amount of torque available in the spindle. So, but there's no reason they couldn't run a 10 millimeter tool.
Okay. And then Deviant Clockwork asked if it's going to have its own frame or be a tabletop, which we're still sort of deciding.
Yeah.
We're experimenting with that.
We are experimenting with that. It's a good question, because the rapids of the machine, there's just so much mass in the machine that when it changes directions, its rapids are 600 inches a minute about, and so it will move the table.
It's a little bit scary.
It can be. If you don't have a table that's really well mounted, like we don't really have any tables around here that are really well mounted, so it does move them around. So we're looking at that. Yeah. Let us know what your thoughts are on that, and because we'd love to get some outside opinions.
And then AJ asked option for probing, which I believe is yes.
Yeah, we were working on that. I can't share the details because we're.
You can just say yes.
Yes. Yeah, right. But it's good. It's going to be really good.
Okay.
Or at least I hope so. If not, it'll be available, but not in school. Anyway, yeah. What other questions you got?
I think that's it.
Okay.
Winston gave some feedback. Thanks, Winston.
Oh yeah, thanks, Winston.
Yeah.
Let's
keep going with the tour.
Yeah, let's do that.
We might want to stay inside just so the Wi-Fi stays connected.
Oh, yeah, okay. Once again, if you're just joining in, that's the Doosan, and it's mostly run robotically. This is the Haas where we prototype most of the new machine's components, and we got it for that prototyping purpose. Here's one of our old taken apart machines. This was a version 2, and now we just slowly steal parts off of it. I do need to do a full tear down on it soon.
New machine will be different.
The new machine will be different. It has some similarities, but it's different. Anyway, we got what we needed to out of that one and moved on.
All right. It's going to get a little bit loud with the door opening.
Oh yeah, here's some of the stock.
Oh yeah.
So this is like, this is an X-carriage block. It's 2.5 inches thick and heavy. I don't know what it weighs. I don't know if it's 10 to 3 inches thick and heavy.
Yeah.
Yeah.
Oh yeah, we're not going to be doing the new machine on Kickstarter. We'll be just releasing through our website.
So it's Friday, so it's very, very quiet in here. And there's not...
Well, most people work 4/10s.
Right.
Yeah, so Friday can be a quiet day.
Yeah. But yeah, this is the assembly line for the V210 and V250 stuff. This is Ethan. Ethan is an avid climber, biker, jeepist, and if you have bought a machine in the last year,
No,
Ethan,
longer than that.
or longer, Ethan has built it. Well, I was just saying because there have been other people that have assembled, but Ethan he has done all the assembly in the last year and a half. Okay, and yeah. Anyway, this is our expensive shelf. So if you're gonna rob pocket, this is the one to go for. This has each one of these spindles is very expensive. There's a whole bunch of them. And then there's like these bearings, and if you buy a pocket, each one of these bearings it costs us $104. So yeah, it's not cheap, hey?
There's a couple more questions that came in too. So
Yes.
for existing owners on the new machine, we have an update list actually. So you can just email info@PocketNC and ask to be put on the new machine update list, and we'll be making announcements first. Ed, yes, that was the new name. And then AJ asked about financing. We're still trying to figure that out. So we're not quite sure if financing will be available for the new machine.
Yeah, somebody would
Probably,
I
yeah,
can imagine
probably
it
yes.
won't be. Yeah, right.
Yeah. So we just need to figure out some details there. But
Yeah, and we even get that question from our own banks, right? Do they?
yeah, for sure. Yeah.
I'm assuming something will be available.
Ooh, people like the Solo.
Oh,
I heard it here first.
Yeah, right. So yeah, we have been calling it the Solo, but we haven't. We haven't really showed that publicly until now.
Yeah, and we're not going to release a CAD model of the new machine. We don't have that yet. I'm not sure. It just said, are you going to release a CAD model of the new machine fully assembled?
For what?
The new machine.
But for what?
I'm not sure. So,
I mean,
anyway.
probably we'll definitely have to release something.
Yeah, sure. Like footprint and things of
Yeah,
that
right,
nature.
so
But yeah.
there'll be some stuff.
Something. Yep.
And obviously, like the table stuff will release. And,
Oh, yeah.
And the work envelope and stuff like that. I know it, right?
Yeah.
It's nice. We'll just have to see, because it also, when a lot of people, I guess, really do want to use the stuff that checks their work and make sure there's not collisions and stuff like
Right.
that. So,
Right. Yeah.
we'll just have to figure that out.
Yep.
This is cool. This is.
Oh yeah.
So when we first moved here, we started getting this. I'll say it wrong, but babuka. It's German. It's beech wood that they put together in Germany. Anyway, they make for nice tabletops, and we used to always just do plywood tabletops, and they would get destroyed, and then you'd end up with like this wood fiber and stuff. And it is nice having a wooden workbench, but it's nice having a wooden workbench that lasts. So if anybody is looking for a good thing to make a bench out of, that's it. Yeah, so this is the whole assembly line. We start with parts from anodized. So once they get done being machined, they come in, or they head out for anodized in Spokane, Washington, and then they get shipped back to Montana. We go through them, inspect them, and then we start installing different components on them. Yeah, a bunch of bearings, any of that stuff right now. But and then we work down the line. We build the main block assembly here, and then it gets put right over here, and it waits. And then right here, our trunnion assembly gets built and works down this line. It gets its final inspection right here, and then the trunnion assembly gets put right over here. So you can see this one's done, and then an X carriage assembly gets built here, and the spindle motor gets put on. This is Ethan's one of his tools. This is what's the diameter? Is it 25?
Yeah.
This is solid carbide. This is a foot of solid carbide, 25 millimeters long. And we use it to measure the straightness of the spindle. So one thing that's pretty important is when your machine travels in Z, or really in any axis, but when it travels in Z, that it doesn't like deviate to the side, right? So if it travels down in a non straight path or not perpendicular to the other axis, it makes it difficult to make any kind of good part. So we first set this up in a high-speed spindle mount, and we tighten it down with the bearings and everything on it, and we can check it with an indicator across these blocks and make sure that it's straight. The reason we went with a solid carbide is because when we went with a 25 millimeter just regular steel block, we ended up with I think it was like 7/10 thousandths of deviation. Like just the standard wasn't as good, and so it made it really hard to get people a perfect machine. Yeah, anyway.
Q asked if you could speak up just a little bit.
Oh yeah, okay. So yeah, and then the last step is putting in all the electronics and wiring it up. Well, I guess that's one of the last steps. This is the last step in the assembly. So yeah, it worked way down in this bench, get everything on there. And what am I missing?
Wire it up and
Yeah.
calibration.
Yeah. Can I hold that for just a second? We have like a bajillion DeWalt drills. And what we found is that when you install like 10,000 fasteners, don't want to have to deal with putting in a different bit for each one and having a different torque and just messing with that. And it's how things kind of get messed up. So it seems like we're always adding dewalt drills, but that has been awesome. Just being able to count on having the right tool each time. Ooh, this is some of the electronics.
Displayed all the electronics in the machine.
And then the circuit boards are on this shelf. Here, Carrie, you should come over here and show them.
I'm gonna get right behind you. All right.
All the buttons, switches.
And then all the circuit boards and CPs.
Motors.
Yeah.
And then Tanner asked if Matt is working on his machine.
Oh yeah. Here, come over here.
Is that Tanner's machine, Matt?
Yes.
Oh.
Tanner, that's your machine being worked on by Matt. This is our service engineer, Matt Rounds.
Hi guys. This is the desk where Q and I work and repair all the machines. We've got desks upstairs too for emails and phone calls, but this is kind of our diagnostic bench. So
Excuse the wall behind you guys.
Oh yeah. Yeah. That was the modification.
So right now with this machine, there's a short somewhere, and so we're going through and checking some diagnostics. Right now it's looking like maybe there's an issue with the main board or the air pressure board on this V250. So just kind of going through methodically and testing with the multimeter and running some tests that we have in there and locating where the issue seems to be.
Dew and Cloudberg asked if that's your stress relief wall.
Yeah. When the machines come back dirty, this is what happens to our wall.
Cool. Thanks, Matt.
This is cool. So some of our electronics have to have a glue around them so like debris don't get in and cause internal shorts. And so should come in on close on this Carrie. So we can put glue in the connector, and then it just sits there, and it's totally liquid until you put. Don't look up at the CRS.
I know, I won't.
And then it's totally cured. So now it's like you can touch it, and it's not going to do anything, go anywhere. So yeah.
We've had a few questions about the new software for the new machine, and we're actually going to be having an update about that in just a few weeks, like the end of October. So there'll be posts and information definitely coming on that. And we're going to have a simulator for the new machine too, yeah? John's working on that?
Yes.
Yeah, so that will also be available. So the new interface we're actually shipping even before the new machine, and that's going to be real soon, November 1st.
Yeah, so this is, some of our circuit boards are still made here in-house. This is actually an old pick-up press machine from SparkFun Electronics, if we were bought anything from them. They had this and gave us an incredible deal, which was super kind of him. We used to make all of our circuit boards here, but we've been trying to utilize our time more to prototype and design and push off some of that stuff that's repetitive to companies that just have the right equipment and for checking and producing boards. So like this machine's a little old, it drops a lot of components, and so it does cost a little bit more to make boards. Yeah, it's been great. It's got us where we are today. And this is
Hi, Billy.
Billy, our electrical engineer. He makes most of he makes actually all of our new design stuff. And yeah, why don't you tell us what
drawing up the boards for the solo.
Yeah.
Figuring out how to lay out everything so we don't have issues.
Yeah. But and there's like quite a bit more amperage and I guess safety stuff that has to be on this machine. So there's a lot more sensors and a lot more wires to manage, and just because the machine is bigger doesn't mean there's significantly more space. And yeah, it ends up being a good deal of work. Yeah. I don't think we're covering probe stuff, are we? So I'll just skip this.
Yeah, you can skip that. Yeah, somebody did ask if thanks, Billy. Yeah, the new machine can cut stainless steel 303. That will be totally fine, and the current machine can do that. It's just slow. So.
Yeah, I think one of the big things is just like, I mean, obviously rigidity is super important, and that's why we're making a bigger machine. And with some of these stainless metals or just like harder metals in general, right, the feeds and speeds become increasingly important. And so the spindles that we have here right now are those 36,000 RPM spindles or 40,000 RPM spindles, and their torque curve is significantly higher than we would want for cutting those materials, and that's why we're looking at going with maybe a slower spindle for operating. People love high-speed spindles, and I'm like, we all watch like Ed Kramer's videos of how fast he can cut aluminum and stuff, and that's great, but you know, it really is just so application specific. What kind of spindle you have, and I think one of the reasons you see like a 20,000 RPM spindle on Doosan machines or DMG machines, or you see like even Haas is coming out with a lot of high-speed options, is because people do cut a lot of like aluminum stuff where you can have super high feed rates and super high cutting speeds. But I think we'll just have to have options for people to be able to do things like that, and we'll just have to be aware of like what the bulk of what you're going to be doing is, so that you can make those decisions right. This is another sort of prototyping area. This is Ethan's bench. So he's been working on a new device. He's got a sweet new tool, it looks like, for doing that. A little 8mm boring bar setup from Big Kaiser. Yeah, hopefully we make some more progress on that soon. Just been busy with prototyping quite a bit these days, so that's a little slow. This is also prototype stuff. We have a lot of stuff we've gathered over the years that we need to get rid of. I think that's kind of the nature of inventing. Yeah. This was version 2's electronics cabinet with version 3, the version 3 machine. It's not on right now, so I just manually operating the carousel nodes.
Just a lot easier.
Anyway, so if you come in here, one of the things we're doing is testing a little turbine.
Oh yeah, the turbine.
It wasn't
Hard to see in white Delran.
It's very difficult. But just honestly running feeds and speed tests, making sure like it goes to the right position, checking feedback on motors, making sure the user interface is responsive and fast. But we had some issues with the third version of enclosure, and so we decided to change it again and go for something a little different. You can see so on the second version we had quite a bit of excess wire and stuff, and so that's one of the things that Billy's working really hard at, is trying to reduce some of this wiring to make it a lot more friendly for the people who put the machines together and the people who service it, as well as if you're in the field and you want to add a new like circuit board that we've come out with in the future, then you'll want it to be nice and clean and easy to access. And yeah.
And one other question about the new machine, we are using ClearPath servo motors. Somebody
Yes,
asked
we
that.
are.
So
Yes.
yes. Yep.
They're just too affordable and reliable, and they're too easy to count on to not use, right? Like everything about them is just really well done, and the people who make them are incredibly smart. And yeah, so it was kind of a no-brainer on using their stuff. Yeah. Yeah, so then we got some like 3D printer stuff over here that we've worked on. We, prototype a bunch of little stuff here and there. Yeah, they're pretty good. We used to have the Form 2s. We also have this Dual 3D. That was kind of like a failed attempt at dental stuff. We didn't realize that dental people maybe need a little bit more hand-holding than a lot of machinists. So we decided to kind of step back from that, but it's been
The printer's just a printer.
a good lesson.
Yeah.
Yeah, and the printer is just a printer. But the Form 3 is probably our most loved printer. That it is significantly more reliable, and the parts that come out of it are significantly better than the Form 2. So if you're thinking about getting a Form Labs printer, it's probably a better time to do it than it ever has been before. This is where we assemble a whole bunch of our enclosures. Enclosures are, some are made in Bozeman, here where we're at, and some are made in
Spokane.
Spokane, and then, wait, I don't know the third place, is that in Spokane as well? Mm-hmm. Yeah, okay. Yeah, it's just enclosures. This is our shipping and receiving area. I haven't told anybody about this, but this is so if you look around and you see these boxes of linear
All
bearings,
the boxes.
and you see up there, and you see over there, it's like $1.25 million worth of bearings that we got at some crazy fraction of the price, like pennies on the dollar. Anyway, but the cool thing there, so it was a repurpose, kind of like a recycle thing, that a long time ago MakerBot had a competitor come out with a machine, and I believe that was, I think it was 3D Systems. I'm almost certain of that, but and that they built this printer. It was a huge flop, and they used the exact bearings that we used from the exact manufacturer, and they just sat for the longest time. That was a super cool find for us. It helps us keep our machines down, helps us provide really good products by using really nice bearings, and it was cool that they didn't just all go in the garbage, because it was just like a fluke that they were the same size and the same length that we needed. Anyway, so that's pretty cool. But so we have a few extra rails there. Yeah, and so if you buy or send anything from Pocket C, you'll think where it goes. Let's head upstairs. I could use a glass of water. This is Carrie's office. Carrie's currently the one filming all of this.
It's so messy.
This is like everything at Pocket NC, hey?
Well, no, not really. The machine shop's very clean.
And she makes all of the sales from that computer right there. Yeah. That computer's done a lot of business. Oh, don't hold it there.
Oh yeah, right. Got it.
Oh
boy.
This is
Oh yeah.
Daytron Dan sent us this awesome longboard. It does get some miles. That sticker does not feel like it's miles, but it's actually a Band-Aid sticker. So I think from an injury somebody sustained on it. Super awesome gift. We got this right before COVID from him. So.
Yeah, was that West Tech 2 years ago? Yeah.
Yes, it was.
Yeah.
We should go see the service area too.
Okay, we are right at an hour,
Oh yeah, sorry. I'll hurry up it.
but yeah.
This is Scott. Scott enjoys
Snacks.
environment. Yeah. This is his natural habitat with snacks. He loves to work out, build machines, or not build them, but
He
calibrate
calibrates.
them.
Yeah, he's our final test
Yeah,
technician.
and then, also handles, I think, most of our shipping and receiving. So, yeah, and then
Which is also ready to go, Gary.
Okay.
Uh, and then we'll head over to the service area.
Okay.
This is pretty cool, actually. We do use liquid nitrogen for some of our spindle assembly stuff, and it's cool because you can like pour a little on the floor, and it will just. Oh, I can't quite see it on the camera. You can maybe see it there. They just like.
Yeah, hard.
You see that?
Yeah, that was a little bit better. Yeah.
Pretty cool stuff. But you can't like dip food in it and stuff because you can get injured.
You know that, Matt?
I don't know anything about that. Neither do you. Oh, this is our bathroom slash circuit board oven facility. So all of our boards get washed with deionized water in there, and they go through. This is our little circuit board oven, and then we have a laser for doing some part engraving. And yeah. Anyway, it also has a toilet and a sink, so it's multi-purpose. And this is the service area. So anytime you call in Pocket NC to get help with something or send an email, this is probably where it gets answered.
Oh yeah, and we have our museum shelf.
Oh, yeah, right. Yeah, so
Yeah.
filming stuff happens kind of over here. This is Matt's desk.
Oof.
What?
Just spinning people around
Oh,
a
yeah,
lot.
Sorry.
And this is our new machine suits enclosure. Those folks are in California.
Oh yeah, it's a pretty nice enclosure. I totally recommend picking one of these up if.
Yeah, we'll be offering it
don't-
again soon.
Oh, cool.
Yeah. Yeah,
Yeah.
that's about it.
Cool. Well, thanks, guys. Thanks for taking the time to join us and take a tour of Pocket NC.
Yeah, thanks. We appreciate it.